Hi there. I'm getting ready to introduce the assignment that will allow us to make mass-to-mass calculations in stoichiometry. And the first assignment that we're going to do here is going to be you writing down examples. There will be 3 of them of 3 mass-to-mass stoichiometric calculations, and doing that while watching a video that I'm preparing for that. So if you see that part A says watch a video or view the stoichiometry assignment notes, there's a PDF copy. I highly encourage you to watch this video rather than resort to that, because I will model the questions. So in this video, I'm going to go through 3 examples, and each of the 3 examples for mass-to-mass calculations will be done using this roadmap, of which I'm going to demonstrate shortly how to use. So there will be 3 examples, and then after that you're going to have to, after you've copied down exactly what I've written, you have to make this table for molar mass calculations. And this molar mass calculation table has 4 done for you already. So you have to complete it. This will give you all of the molar masses that you need to complete the second assignment in this mass-to-mass calculation unit. So the resource that we're going to use and that I'm going to reference is this one right here. It's a Stoichiometry Roadmap Mass-to-Mass Calculations tutorial. So if you remember using the roadmap for mole calculations and mole conversions, it's a similar concept. So in a stoichiometry problem, we are always interested in 2 things. And the first thing is something that we know information about. It's associated with a number. And the second thing is what we're trying to get information about. So with this roadmap here, you will use it as a guide for solving problems. And it's color-coded here, so you can use this as a reference. Anything having to do with the substance that's given is red. So I look for a number. I don't know why that happened. So I look for a number, I put a block around it, and this is going to be my substance A. A is always something that we know a substance about. Now I'm not color coding in this with my ink here. So, and then the second thing that we're interested in is what there's a question about. So how many grams of carbon dioxide? So that is my B. So what I want to do is I want to put on the equation itself, I want to put a box around my A and label it as such. That's my A. And I'm going to put a box around my B and label it as such. So the first step is writing down the given and the number. The next step is a mole conversion. We're converting from grams to moles of A. Wherever there is an A in this map, we put the formula for A, which is this. So you'll notice that down here I have the formula for A, the formula for A, the formula for A, and the formula for A. And those correspond to all of these spots right here. This next step is called our mole-to-mole ratio. And the mole-to-mole ratio comes from the balanced chemical equation. So I have my A on the bottom, I've got my B on the top. There's a 2 in front of this C2H6, and there's a 4 in front of the CO2. So for every 2 moles of C2H6 on the bottom, there are 4 moles of carbon dioxide. So I've taken care of my mole-to-mole ratio. The next step is converting from moles of carbon dioxide, which is our B, to the grams of carbon dioxide. And to do that, I have 1 mole of B, which is carbon dioxide. Notice that I have a B here, a B here, and a B here. B is CO2, CO2, CO2. 1 mole of that has a mass of 44.01 grams of carbon dioxide. So using this Super Mario method that I talked about, Super Mario takes a specific path, and this path goes like this. Oh, that's not really staying put, is it? I'm going to bring him to the front. There we go. So Super Mario does this. Dun, 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 dun. And every time he goes from the platform that he starts with to the top of a block, we multiply, and every time he goes down, we divide. So done. This is pathway from here to here, from here to here, from here to here, and then we hit equals. So he will follow the green arrows, and this has just gotten away from me here, sorry. And we use the Super Mario method in the calculator. We type in, I'll put the green arrows back on. So we go from here to there, top to bottom, and then equals. So we would type in 786.4 times 1 divided by 30.8 times 4 divided by 2 times 44.01 divided by 1 equals. So we can do that in one swoop. We only hit the equal sign once, and we get 2,301 grams of carbon dioxide. So this was just a visual. The next part of this video is going to show you examples, and in that, for each example I show you, I am going to want to show you to show all of these things, and this will be made available to you in the assignment that I give you. So you have to write down the question, you have to write down the balanced equation, you have to show A and B, and you have to show the calculation. So everything you see here in the black writing is what's going to need to take place. So the next segment of this will be beginning to go through these examples. So now I'm going to go through these calculations, and this is what I want you to copy down. I have the map available to you, so the first thing I'm going to want you to do is copy down the map in your notes. So you should pause this before I continue and copy this molar roadmap in your notes and continue to reference it. Or a better idea would be to copy it in the on a piece of paper that you can use and go to as a reference the whole time. So here is, we've got the roadmap on the top. I'm not sure if I'm covering that up or not. We start with the given number, we end with, and that's A, we end with B. Here is the question: how many grams of iron chloride will be produced when 206.9 grams of Fe2O3 reacts in this equation? So in all of the examples in this assignment, I'm giving you the balanced equation. So if we look at this balanced equation, the coefficients are here. We have 6, we have a 1, it's assumed to be 1, we have a 2, and a 3. The first thing I'm going to do is look for the number, because that's going to give me my A, and I'm going to put a box around it. 206.9 grams of Fe2O3. All right, I know that Fe2O3 is my A. Wherever I have A in my roadmap, I'm going to write Fe2O3. Down here for step 2, I have, or step 1, put a box around A and circle B. How many grams of FeCl3? So that's my question. FeCl3 is my B. I could put a box around this and a circle around this too. All right. Now the next step, find the molar mass of each. All right. The molar mass of iron is 55.85. So I have 2 times 55.85 plus 3 times 16.00 equals, I have it written down here, 159.70 grams. Okay, I'm going to find the molar mass of this one. Now, again, I'm not thinking about the 2 right there. I have 1 iron, so I have 1 times 55.85 plus 3 times 35.45. And I have that one written down as well, and that is 162.20 grams. All right, so I have shown you the work here, and I've come up with the totals. And if you remember what I said earlier, I'm giving you a strong hint that this is an answer for your molar mass calculations. All right, step 3, write the beginning and the end. By this, I write the beginning, I always write the number first. I have 206.9, that's my given number, grams. I've written grams of A. A is Fe2O3. Now I'm going to give myself all kinds of room here, and over here, write what I'm trying to find, the end, grams of FeCl3. All right, so step 1, box the A and circle the B. We identified them. We found the molar mass of each, and I wrote the beginning and I wrote the end. Now we want to plug in the values using the roadmap. So you can, if you want to, you can draw a grid like this. I can't keep these lines straight, it's really hard. Or you can just continue in the same style that we've been using. So in this first conversion factor, I have 1 mole on the top. I have to write 1 mole because that's written in black. And I have to write Fe2O3 because that is what A is. The molar mass of Fe2O3 is 159.70 grams of Fe2O3. All right, so I got this first conversion factor done. The next conversion factor, I like to put the box in there. I have moles of A on the bottom. A is Fe2O3. And I have moles of B on the top, which is FeCl. And here, I'm going to get these numbers from the balanced equation. So I have a 2 in front of my FeCl3, so I put a 2 there, and this is a 1. All right, so I have my mole to mole ratio step done. And my next step is 1 mole. I'm writing 1 mole because it's written in black and I have to write everything identical, of B, FeCl3, and the molar mass of B, which is 162.20 grams of FeCl3, equals, now in the calculator, Mario, because he wants to get to Princess Beach, will take this pathway. So in the calculator, you will type in 206.9 divided by 159.70 times 2, and then this divided by 1. So I skipped the divided by 1 because we don't include it. So I'll start fresh 206.9 times 1 divided by 159.7 times 2 divided by 1 times 162.20 equals, and that value is going to be 420.3 grams of FeCl3. So the next slide is another problem. How many grams of C8H18 will be required to produce 15.06.4 grams of CO2 in this reaction? One thing I want to point out on this side is in this problem, my A happened to be on this side and my B happened to be on this side. And it's not always going to be the case. So in this example, I'm going to find the number. This is my A, grams of CO2. So my A is now on this side, and my B, how many grams of C8H18, is going to be this side. So I'm going to put a circle around my B and a box around my A. So I boxed A and I circled B. Find the molar mass of each. I went ahead and did that to save time. I have them written here. Write the beginning and the end. The beginning is the number, 1,506.4 grams of A, which is CO2. Okay, so I've gotten that. And I'm going to write the end, which is how many grams of C8H18 will be required to produce this much carbon dioxide. All right, so I have got my box, my circle. I found the molar mass of each. I wrote the beginning and the end. And I'm just going to start the steps now. So my first conversion factor, I have 1 mole of A. In this case, every time A is CO2. The molar mass of A is 44.01 grams of CO2. It is extremely important that you write these units down. If I'm looking at your assignments and you don't write the units down, I am going to immediately give you a 5 out of 10 and tell you that you need to do that in order to get full credit. All right, so I've got this step done. The next is my mole to mole ratio. Again, I like to put the box in. Moles of A on the bottom, CO2, related to moles of B on the top, C8H18. And looking at the numbers in front of my B, I have a 2, and in front of my A, I have a 16. So 16 CO2s and 2 C8H18s. All right, I've gotten that taken care of. Times 1 mole on the bottom, 1 mole of B, C8H18. And the molar mass is 114.26 grams of C8H18. And when we plug this into our calculator, we get 1,506.4 times 1 divided by 44.01 times 2 divided by 16 times 114.26 divided by 1 equals, and that gives us 488.87. So 488.87 grams of CH818. So on the first problem, the A was over here, the B was over there. On this problem, they were opposite. On the next problem, we're going to see that they're both on the same side. So how many grams of oxygen are required to react with 456.2 grams of hydrogen in this reaction? So here's my balanced equation. I put a box around A. So my A is hydrogen. And a circle, how many grams of oxygen? So this is my B. Here you see A and B are both on the same side. And sometimes you might have B here and A there. We're always interested in two substances, and we're not worried about anything else. Step 2, find the molar mass of each. I found that and included it to save time. Step 3, write the beginning and the end. 456.2 grams of hydrogen. We have to include the formulas. And the end, we're looking for grams of O2. All right, plug the values in using the roadmap. I've got my beginning, got my end, times on the top 1 mole of A is H2, is 2.02 grams of H2. Then in the mole to mole ratio, we have 2 moles of H2 for every 1 mole of O2. Remember, this is implied to be a 1. So this 2 is coming from here, and this 1 is coming from here. And so I've got this step, I've got, this is kind of acting up on me. And then I have 1 mole of B on the bottom, which is O2. And the molar mass of 2 oxygens is 32.00 grams. 456.2 times 1 divided by 2.02 times 1 divided by 2 times 32.00 divided by 1 equals, and that is 3,613 grams of oxygen. So your requirements for this assignment are going to be this is going to be included as a guide. You don't have to write anything down. You need to watch the video that I am making right now, and you need to copy down, I'll highlight it here, you have to copy, you have to copy down all of, I'll circle in, so I want you to copy down the problem and the solution, and that is what I want you to show. You don't really have to show this stuff. You will not have to show this either, because before you start any of the problems I'm going to give you, you will have already calculated all of your molar masses. So I want you to write down the question, I want you to write down the formula, and then the solution. And for each of the 3 examples that I gave, so I'm going to look for the roadmap, I'm going to look for the 3 examples, and then I'm going to look for this table completed right here. So again, I've given you some of these already from the presentation, but I want you to have that available. Now, so this assignment is just, the only thing you're doing is copying down my examples, just like I have, and you're calculating these molar masses, and you're sending me a picture of that. The next assignment is going to be for you to solve 5 problems like this. And it shouldn't take too long. I'm giving you all of the balanced equations. You will not have to balance equations. You will already have your molar masses calculated. And here's the thing. You're going to get 5 questions from a question bank. So you are, I have 50 questions in the question bank. So you are going to get 5 separate questions out of these 50. So the likelihood of you getting the same questions as your friends is very, very slim. So I know that some of you have been working together, and I don't mind collaboration, but this is going to make sure that you are really thinking through each problem, because it's going to, that the question set of 5 questions that you get are going to be very much your own. So I'm going to open that assignment up, the second assignment up, right away. So the time of this recording is a time during COVID-19 when we're at home, in which we're given 2 assignments per week. So if I ever use this video again for any other reason, this is what I'm talking about. The first assignment this week is to copy the notes down just like I did, and the second assignment this week is the first assignment is to copy these examples, calculate the molar masses. The second assignment will be for you to calculate or solve 5 mass-to-mass problems. So I'm going to open it up in case any of you do want to get started right away. So thanks for watching.